Okay, now let's talk about the edges. We can pick an edge with Pick tool, in Edge mode. Similarly to vertices, curved edges has an important parameter called editing normal. The editing normals controls how the shape of the model must bend across the edge. We can change it to actually change the shape of the two polygons on the two sides of the edge. Pay attention, because any change to the handles of the curve or to its vertices may affect the editing normal on the edge. If the shape of polygons looks messy, you can reset the editing normal on the edge in many ways. For instance, there are 4 different tools here in the dedicated inspector. They works with different mathematical strategies, but I'm not going to discuss that here now. Usually the best is axis normals, or also edge normal. That said, you are free to try all of them and choose which one looks better. Now, let's say we have selected at least one polygon. The dedicated inspector here may have a section called Polygons Filling Algorithm. This depends upon the selection mode in use. To have this section you need to be either in Polygon mode, or Parts mode or Rings mode. This section controls how real polygons are generated inside curved polygons. Let's use the selection wire option on this scene. As you can see, a curved polygon is made of a lot of triangles, but how do we generate them? Again, there are complex mathematical principles we are not going to discuss here. What you can do is to choose among one of the 4 selected algorithms here. The half-corner schema is actually the default and most precise algorithm we use. If you generate new primitives or new polygons with the other tools, they will all be already using the half-corner schema. If you have all models made before version 1.3 of the editor, they may be using one of the other algorithms, since this one is the most recent. That said, also the edge surface schema is good, and it was the default in version 1.1 and 1.2 of Curved Poly Editor. As you can see, each algorithm changed the shape of the polygon, so you should consider to choose which algorithm to use on each polygon, since you can. Cylindric Interpolation is the most fast of the 3, and it was introduced with version 1.0. Be aware that this algorithm ignores the edge normal, and it does not work towards making smooth edges. That said, there are still situations in which it makes smooth edges, that is when the left and the right side handle of an edge are aligned. For instance, the sphere primitive looks good even with cylindric interpolation, and even after some change is made. The issues come when we break the alignments around the edge. As you can see here, we get an horrible sharp edge we don't want. If this is the case, we shall just move to the other algorithms. Now the edge is smooth. On the other side, cylindric interpolation is faster than the other algorithm to compute. Considering that you don't always need to have perfect polygons, for instance because you are working on little details, and considering you can mix different algorithms on different polygons, it makes sense to keep using it. Again, if speed is what you are looking for, you can choose Garou interpolation. This is an even faster solutions, working the same as cylindric interpolation, but simplifying the way in which normals are computed, making the overall process even faster. We have discussed almost everything about shaping. There is left a section here called Shaping Options. This section is responsible of a few important options which controls how the model will react to shaping actions. Let's start with elasticities. If you pick a vertex and move it, the edge is attached to a change shape. Let's look at this edge for instance. This happens because one side of the edge is changing, while the other side of the edge is not. This is pretty much common in graphics softwares which use curves. Here in Curved Poly, you can ask the editor to do something about this. Elasticities indeed controls the way in which edges reacts to reshaping actions. The most simple option, but not the most recommended, here, is Clayish Mode. In Clayish Mode, the edge does not react to shaping at all. This is what happens in most of the other graphics tools around, so we think you should use to it. The other elasticities works in this way. They change the length of the handles of the edge, to match some shaping action. So if I move this vertex, with this handle picked, the handle change its length during the process. So, with a proportional mode, active by default, if the length of an edge decreases, also the length of the handles decreases. Proportional mode follow the principle of keeping the shape of the edge the way it is, under some transforms, by scaling the edge proportionally. The opposite to proportional is elastic. In elastic mode, when an edge length would increase, the handles react like springs reducing their length, and if the edge length decreases, the handles react by increasing their length. The principle here is to make the edge work like a spring indeed, making its shape change drastically to match as much as possible the original length. Last, but not least, we have the elliptic elasticity. This works in a way which is similar to proportional, but it stretches the shape of the edges such that elliptic arcs keep being elliptic arcs, so it works very well on shapes which has been designed to have circles or ellipses. Furthermore, while you are shaping a group of elements, you can try out the elasticities and choose the one which looks better for you. To do so, you just transform your selection a bit, then you go to Shaping Options and change the Elasticity mode. This will recompute the transform on the selection, updating the edges which are affected by elasticity settings. Another important group of tools here are the ones which control editing normals on groups of elements. We have already covered the role of editing normals, both on vertices and on edges. As you can see here, we have three options which are similar to the ones used for edges normal. The difference is that, like elasticities, these options applies by default on all edges which are changing shape. Again, by default the option here is the axis normal, which is usually the best solution, but you could try to work with the others. Now, let's say we have an editing normal on an edge, which has been set up somehow. While the edge is changing its shape, the edge normal algorithm is on a best effort to keep your edge normal as close to the one you have assigned. Each algorithm does this in a slightly different way. Here, there is also the update selected edges normals, which affect all the selected edges at once. Be aware that in this way, any change you have manually made to editing normals will be lost. Again, there is the option to fix all the normals. This works by recomputing all the editing normals on selected vertices first. Then, also the editing normals of edges attached to that vertices are resetted. During fix normals, a lot of things happen, since the software will check almost every relationship between edges and vertices, and eventually fix them. This is, for instance, an important step to take if normals are messed up, since everything gets recomputed.